Stars are luminous spheres made of plasma, a superheated gas threaded with a magnetic field. They are made mostly of hydrogen, which stars fuse in their cores. That process releases energy, which pushes against the weight of the outer layers of the star and keeps it stable. The energy is also released as heat and light, which are radiated out to space. Stars are the main components of galaxies, and were among the first objects to form in the early universe. The closest star to Earth is the Sun. Facts about stars: there are 9,096 stars visible to the naked eye in the entire sky. To see more, you have to use a telescope to reveal stars fainter than your eyes can see. You can only see about 2,000 stars on a very dark night with the naked eye from any given place on Earth. To do this, you need to observe on a moonless night and be far away from sources of light pollution. Astronomers estimate there are 1 trillion stars in the Milky Way galaxy. Stars are born in batches in their stellar nurseries. Over time, they travel through the Milky Way, far from their creches. Most stars travel the galaxy with companions or in clusters. But not all stars do that. Our Sun, for example, moves through the galaxy without a stellar companion. When you look at a star, or any object in space, you are seeing how it looked in the past. The Sun appears as it was 8.5 minutes ago. The view of Alpha Centauri is 4.3 years old, while the appearance of Sirius is more than 8 years old. The more massive a star, the shorter its lifespan. A very massive star may live only tens of millions of years, while a cool dwarf will shine on for billions of years. At an age of about 4.5 billion years, our Sun is considered middle-aged. The oldest accurately dated star chart appeared in ancient Egyptian astronomy in 1534 BC. In 185 AD, Chinese astronomers were the first to record a supernova. This is now classified as SN 185. The furthest distance an individual star has been observed from is about 100 million light-years from the Earth in the M100 galaxy of the Virgo cluster. How stars form: star formation happens in clouds of interstellar gas and dust called nebulae. These clouds are mostly molecular hydrogen, and are often referred to as HII regions. The process begins when the cloud is nudged into a spinning motion, perhaps by a shock wave from a nearby supernova explosion. Clumps begin to form, and they get hotter and hotter as they gain more mass. When the temperature inside such a young stellar object reaches 10 million degrees Celsius, a process called nuclear fusion ignites, and a star is born. Star birth can take millions of years and create families of stars. Astronomers see examples of star formation in nebulae throughout our own Milky Way galaxy and in many other galaxies. The most famous and closest stellar nursery to Earth is the Orion Nebula, which lies about 1,500 light-years away and is visible to observers from November through April each year. How stars die: stars may live longer than humans do, ranging from tens of millions to billions of years, but eventually, they, too, come to the ends of their lives. The manner of a star's death depends on the mass it had after it finished forming. Stars with masses similar to the Sun die much differently from stars that have 7 or more solar masses. Yet, the process of star death starts out the same for all stars: they run out of fuel. For much of its life, a star fuses hydrogen to make helium. When that runs out, then the star fuses helium, and then carbon. Each level of fusion releases more energy, which heats up the star. In Sun-like stars, the increased heating causes them to swell up to become giant stars. Any nearby planets are enveloped by the expanding star. Eventually, the outer stellar atmosphere blows away, creating an expanding cloud of gas around the star. This is called a planetary nebula. What's left of the star itself slowly shrinks and cools. Eventually, the dying star becomes a white dwarf. Stars that are much more massive than the Sun continue the fusion process until they reach a point where the core collapses. The outer layers also collapse onto the core and then rebound out to space in a catastrophic explosion called a supernova. When stars die, all the elements they created in their cores are scattered to space, to become part of interstellar clouds of gas and dust. Those chemical elements are seed materials for new generations of stars, planets, and life. Types of stars: astronomers sort stars into categories according to their spectral characteristics, that is, the information contained in the light they radiate. The general categories are O, B, A, F, G, K, M, R, N, T, Y, and group stars, and stellar objects, by their temperatures, luminosities, and colors. For example, O and B-type stars are blue-looking and are generally among the hottest stars, between 30–40,000 Kelvin. A-type stars are blue-white and have temperatures around 9,500 K. The F-type stars are white and are no hotter than 7,500 K. The G-type stars are yellow-white and around 5,900 to 6,000 K at the cooler end of the spectrum. The K and M stars are orange and red, respectively, and range from 5,300 to 3,800 degrees Kelvin. The coolest stellar objects are the R, N, T, and Y stars, which include the brown dwarfs, objects too hot to be planets and too cool to be stars. Astronomers further classify stars by such characteristics as their rotation rates, and metallicity, how many elements heavier than hydrogen and helium they contain. In addition, they use some other specific information about their luminosity or the existence of exotic chemical elements in the star's atmosphere. Stars are plotted on a color luminosity chart called the Hertzsprung-Russell diagram. The stars in their hydrogen burning phase fall into a curving line called the main sequence. White dwarfs, giants, and supergiants all fall outside this sequence, showing that they are fusing other elements and thus are in advanced stages of evolution. Famous stars. The Sun. The most famous star in our sky is the Sun, the source of the heat and light that powers the solar system. It's a G-type star that formed some 4.6 billion years ago. The Sun is a yellow-white dwarf that will continue its hydrogen-burning phase, that is, live, on the main sequence, for another 5 or so billion years. Then, it will start to fuse helium, which will heat up the Sun and cause it to expand. The Sun may form a planetary nebula, and eventually will shrink down to become a white dwarf. It will continue cooling for another 10 to 15 billion years. Alpha Centauri System. The closest stars to our Sun are in the Alpha Centauri System. They are visible mainly from the southern hemisphere and the most southerly parts of the northern hemisphere. These stars lie 4.3 light-years away from us. The brightest is Alpha Centauri, which is a double star containing a G-type main sequence star similar to the Sun. It's called Alpha Centauri A. Its companion is Alpha Centauri B, and is a K-type star somewhat dimmer than the Sun and with less mass. The third star is called Alpha Centauri C, or more commonly as Proxima Centauri. Of the 3 stars in the system, it's actually the closest to us. Sirius, Alpha Canis Majoris. The brightest star in our night sky is called Sirius and is also the brightest star in the constellation of Canis Major, the Big Dog. It lies 8.3 light-years away from us. Sirius is the brighter member of a 2-star system. Its companion is called Sirius B. Sirius A is an A-type star that lives on the main sequence. It is twice the mass of the Sun and over 25 times more luminous. Sirius B is slightly less massive than the Sun and is a dim white dwarf star. Sirius was used by ancient people as a way to mark the change of seasons and as a navigational aid for long sea voyages. UY Scuti, the largest known star by radius. One way to express a star's size is by its diameter, which is usually written in terms of the radius of the Sun. Astronomers theorize that the widest a star can be is just under 2,000 solar radii. There are a few stars that reach that size, including one called UY Scuti. It's a red supergiant that measures about 1,708 solar radii, about 2.4 billion kilometers. UY Scuti is a variable star, which means that its brightness varies over time. R136A1, the most massive star. Another way to measure a star is by its mass, which is expressed in terms of solar mass. Astronomers have found a number of very massive stars, such as R136A1, which is in a cluster in the Tarantula Nebula in the Large Magellanic Cloud, visible from the southern hemisphere. This star has 256 times the mass of the Sun and is part of a binary system. No one is quite sure how long R136A1 will last and what it will do when it dies. Some predict it will end in a supermassive supernova explosion when its core collapses. It could also become a neutron star or a stellar black hole. Vega. Alpha Lyrae. Vega is a familiar star to most of us and the brightest one in the constellation Lyra, the Harp. It is also part of an asterism called the Summer Triangle, which is made up of Vega, Deneb, in Cygnus, the Swan, and Altair, in Aquila the Eagle. Vega will be our pole star in the year 13,727 as Earth's pole processes to point toward it. Astronomers found that Vega looks very large in relation to its mass. This is because it is rotating on its axis very rapidly, which flattens Vega. We see Vega from the direction of its pole. Vega is only about 400 million years old, which is fairly young. It is an A-type star and has about twice the mass of the Sun. It will not live as long as the Sun does because Vega will exhaust its nuclear fuel much sooner. Betelgeuse, Alpha Orionis. People often ask which stars will blow up as supernovae. There are a number of known red supergiant stars that could die this way. Betelgeuse is one of them. It's the second brightest star in the constellation Orion, which is visible to stargazers in much of the world from November through April. Betelgeuse is a red supergiant that lies about 650 light-years away. No one is quite sure when it will undergo the transformation to a supernova. Astronomers suspect it could be in the next million years, which is fairly soon in cosmic time. Antares, Alpha Scorpii. Another red supergiant, called Antares, lies in the constellation Scorpius and is visible to observers around the world. Its name means literally, equal to Mars, Ares, in ancient Greek. That's because its reddish appearance is similar to the planet Mars, whose orbit takes it a few degrees away from Antares, as seen from Earth. Antares lies about 550 light-years from Earth, in the direction of the constellation Scorpius. This star is about 10,000 times brighter than the Sun, and has up to 18 times the mass of our star. There is also a companion star called Antares B, which is quite small, perhaps 4 times the radius of the Sun and only about 10 times its mass. Like Betelgeuse, Antares could someday explode as a supernova, and astronomers think that could happen in the next 100,000 years. Rigel, SS Orionis. Orion's brightest star is called Rigel, and it is the 7th brightest star in the sky. Rigel is very bright, about 120,000 times the luminosity of the Sun, and is also a variable star. It has a companion which is, itself, a binary star containing 2 main sequence B-type stars. Although it is named as the 2nd brightest star in Orion, Rigel is actually the brightest most of the time. Its name comes from the Arabic term for the left foot of Jawza, where Jawza was the proper name for Orion.